I'm Dr. J.D. Armstrong. I'm the Maui Technology, Education, and Outreach Specialist at the University of Hawaii Institute for Astronomy. Most of my work focuses around working with teenagers. I think of them as young scientists. This came out of an effort to connect with the community and also to develop the next generation of scientists. I also work with the Faulkes Telescope North, which is part of the Los Cumbres Observatory Global Telescope Network. The Faulkes Telescope North is the largest telescope in the world that was built primarily for education and outreach, so it's a very good combination with the rest of the work I do. The students that I work with, we try to do real research. We are particularly interested in exoplanets and asteroids, comet recovery, and some of them have even been in international news with their work. And so I'm very proud of the work they do, and it's amazing to find these students, so many of these students that are so capable here on Maui. My background is actually in solar physics. My PhD is in astronomy, and my dissertation was written about the energy transport of the solar convection zone. And so when I came here, I was originally looking at doing solar physics, solar research. And life throws some changes, and I ended up working with Faulkes Telescope North and trying to do nighttime astronomy without knowing as much as I really should. And so I have learned a lot alongside of the students that I work with, the young scientists. In a typical year, we'll start at the High Star program. The High Star program is, it starts off as a one-week sort of summer camp for the students to all come together and learn how to do meaningful research. And we bring in some of the other researchers and other guest lecturers. We work with data on meaningful projects, and then the students present their research at the end of the one-week course. And then after the one-week part, then the real work begins. I meet with the students regularly. I'll have students coming in today, and students came in yesterday, and we work on their research. And I always encourage them to enter in the science fair. I like to view the science fair as more of a conference. I discourage them from approaching it as a competition. But I want them to view it as a conference where they can go and present their research, disseminate what they've learned. Now, that doesn't mean I'm not proud of them when they win awards, and we've had quite a few, but I want the focus to be on the science. And my students make me proud on that. They actually are, I'm really proud of how well they are able to put aside the competition and focus on the science. I think this program has led students into becoming astronomers, and this is one of the things that I'm most proud of. We actually have about 7 times as many students that have gone through the program, that have been part of the High Star program. About 7 times as many are working towards doctorates. So we, compared to the national average. Let me see if I can word that in a way that would be useful. The alumni from the High Star program are pursuing doctorates at about 7 times the national average. And one of the students, Erica Sauchinach, she's studying astrophysics at the University of Texas. Another one that I'll brag about is Rochelle Moskovitz. I hope I pronounced that last name correctly. She actually has told us that it was because of the High Star program that she realized that she could make a living doing astronomy. And she is now in a graduate program studying icy bodies and making us very proud. What do I see as the future of the High Star program? Well, we're going to continue doing remarkable science. We're going to have a good time and just geek out on science. That's the main goal of it, is to do something that contributes to humanity's knowledge and enjoy doing it while we're at it. Beyond that, there are currently plans to expand the program, but I would be open to that if we were able to do that. And there's always the limits of resources, and that's a little bit of what we're facing with growing the program. The James Webb Space Telescope, it's just going to be amazing. I've seen some of the images that have come out of it, and it's bringing back that era of the Hubble. And the Hubble was just such an amazing telescope. It exceeded everyone's expectations, and that was before the end of its expected lifetime, and it's still going after the end of its expected lifetime. And so I'm sure Jeff talked a lot about the amazing science that is going to come from this telescope. So I'm going to talk about the inspiration that is going to come from this telescope. One of the students in the High Star program, he seemed to be kind of drifting away a little bit. And then the first images from the Webb came out. And suddenly I'm getting a text on my cell phone of, hey, could we look at these targets that the James Webb looked at and compare results? And so it really is this amazing callback to, when I was younger and I was looking at the Hubble images, and it inspired me. And I think that we're going to be inspiring not just kids, but kids of all ages with the new generation of discoveries from this telescope. The biggest expectations for the scientific discoveries are very distant galaxies, early formation of galaxies. But I'm also seeing they were observing an exoplanet, looking at the atmosphere. And I hadn't thought about that before, but when I saw that, I just was like, ee! Because I get so excited about exoplanets. I mean, this is, what Gene Roddenberry would have said, we're going to explore strange new worlds, seek out new life and new civilizations. And so exoplanets will always hold a special place in my heart because of that. Beyond that, they've also imaged planets in our old solar system. It's going to be such an amazing telescope for the discoveries, and part of my answer is going to be this: I don't know. If we knew what we were going to discover, it wouldn't really be science.